Hello friends, welcome back to Information Systems. I'm thrilled to discuss with you about machine learning in this video. So let's begin. Artificial intelligence, machine learning, and deep learning are the three concepts that help to build this human-like ability into computer systems. Artificial intelligence, or AI, is an umbrella term, while machine and deep learning are the techniques that make AI possible. Machine learning is an application of artificial intelligence that provides systems the ability to automatically learn and improve from experience without being explicitly programmed. Machine learning focuses on development of computer programs that can access data and use it learn for themselves. Deep learning, on the other hand, is a machine learning technique that uses neural networks as an underlying architecture for training models. Simply put, machine learning allows the users to feed a computer an algorithm and immense amount of data and have the computer analyze and then make data-driven recommendations and decisions based on the input data. Generally, machine learning engineers must be skilled in computer science, programming, mathematics, statistics, data science, deep learning, and problem-solving skills. Machine learning is the most widely used branch of computer science nowadays. It is used by many industries of automating tasks and doing complex data analysis. We already are using devices that utilize them. For example, an intelligent assistant like Google Home, wearable fitness trackers like Fitbit, whatnot. There are a bunch of examples around us with ML in use. Applications of machine learning. As I said, machine learning is a buzzword for today's technology, and it is growing very rapidly day by day. We are using machine learning in our daily life even without knowing it, such as Google Maps, Google Assistant, Alexa, and so on. Some most trending real world applications of machine learnings are listed on your screen. Let's talk about some of them. Prediction. Machine learning can be used in the prediction systems, considering the loan example. To compute the probability of a fault, the system will need to classify available data in groups. Image recognition. Machine learning can be used for face detection in an image. There's a separate category for each person in a database for several people. Speech recognition. It is a translation of spoken words into the text. It is used in voice searches and more. Voice user interfaces include voice dialing, call routing, and application control. It can also be used as a simple data entry and the preparation of structured documents. Medical diagnosis. ML is trained to recognize cancerous tissues as a use case. A machine learning process involves creating mathematical and statistical algorithms that can accept input and use some sort of analysis to predict the output. In this process, the first step is to collect the data sets for analysis. Once the data is collected, select the type of algorithm to be used, then build a model around it. Train the model with the test data sets and improvise the model accordingly for future decision making. Most machine learning algorithms can be classified into the following three types. Number one, supervised learning. Number two, unsupervised learning. Third, reinforcement learning. You might be wondering why the fruits and cats and dogs and gaming picture in the slide. Stay tuned. These are my examples to explain the machine learning algorithms to you. I'm sure you will like it, and it will be helping you to understand all these algorithms pretty much deeper. So let's start. Supervised learning. Supervised learning, as the name indicates, the presence of a supervisor as a teacher. Basically, supervised learning is a learning in which we teach or train the machine using the data, which is well labeled. That means some data is already tagged with the correct answer. After that, the machine is provided with a new set of examples or data so that supervised learning algorithm analyzes the training data or set of training examples and produce a correct outcome from labeled data. For instance, suppose you are given a basket filled with different kinds of fruits from the previous slide example. Now, the first step is to train the machine with all different fruits one by one like this. If a shape of the object is rounded and depression at top having color red, then it will be labeled as apple. If shape of object is long curving cylindrical having color green, yellow, then it will be labeled as banana. Now suppose after training the data, you have given a new separate fruit, say banana from basket, and asked to identify it. Since the machine has already learned the things from the previous data, and this time have to use it wisely, it will be first classify the fruit with its shape and color and would confirm the fruit name as banana and put it in banana category. This machine learns the things from training data, basket containing fruits, and then apply the knowledge to test data, which is new fruit. Supervised learning classified into two categories of algorithms. One is classification. A classification problem is when the output variable is a category such as red or blue or disease and no disease. The next is regression. A regression problem is when the output variable is a real value such as dollars or weight. Moving on to unsupervised learning. Unsupervised learning is the training of machine using information that is neither classified nor labeled and allowing the algorithm to act on that information without guidance. Here is a task of machine is to group unsorted information according to similarities, patterns, and differences without any prior training of data. Unlike supervised learning, no teacher is provided. That means no training will be given to the machine. Therefore, machine is restricted to find the hidden structure in unlabeled data by ourselves. For instance, suppose it is given an image having both dogs and cats, which have not seen ever. Thus, the machine has no idea about the features of dogs and cat, so we can't categorize it as dogs and cat. But it can categorize them according to their similarities, patterns, and differences. That is, we can easily categorize the above picture into two parts, or rather previous slide picture. First may contain all pics having dogs in it, and in the second part may contain all pics having cats in it. Here you didn't learn anything before, means no training data or examples. Unsupervised learning classified into two categories of algorithms. Clustering. A clustering problem is where you want to discover the inherent grouping in the data, such as grouping customers by purchasing behavior. And then association. An association rule learning problem is when you want to discover rules that describe large portions of your data, such as people that buy X also tend to buy Y. Now, third on the list, or the last, learning category is reinforcement learning. Reinforcement learning is that an area of machine learning. It is about taking suitable action to maximize reward in a particular situation. It is employed by various software and machine to find the best possible behavior or path it should take in a specific situation. Reinforcement learning differs from supervised learning in a way that supervised learning, the training data has answer key with it, so the model is trained with the correct answer itself, whereas in reinforcement learning, there's no answer, but the reinforcement agent decides what to do to perform the given task. In absence of training dataset, it is bound to learn from its experience. So I want to give you an example. The problem is as follows, as you have seen in the previous slide. We have an agent and a reward with many hurdles in between. The agent is supposed to find the best possible path to reach the reward. The following problem explains the problem more easily. Let's go. The image in the previous slide shows robo, diamond, and fire. The goal of the robot is to get the reward, that is the diamond, and avoid the hurdles that are fire. The robot learns by trying all the possible paths and then choosing the path which gives him the reward with the least hurdles. Each right step will give the robot a reward, and each wrong step will subtract the reward of the robot. The total reward will be calculated when it reaches the final reward, that is the diamond. So that was a fantastic example to explain you about reinforcement learning. Now, the main points in reinforcement learning is that input. The input should be an initial state from which the model will start, and output, there are many possible output as there are variety of solution to a particular problem. Next is training. The training is based on the input. The model will return a state and the user will decide to reward or punish the model based on its output. Next is model keeps continuing to learn, right? That's the beauty of it. The best solution is decided based on the maximum reward. Now, talking about types of reinforcement, there are two types, in fact. First is positive. Positive reinforcement is defined as when an event occurs due to a particular behavior, increases the strength and the frequency of that behavior. In other words, it has positive effect on the behavior. Advantages of reinforcement learning are maximizing the performance, sustained change for a long period of time. Disadvantages of reinforcement learning: too much of reinforcement can lead into overload of states, which can diminish the results. Now, next is the negative. Negative reinforcement is defined as strengthening of a behavior which is negative condition is stopped or avoided. Advantages of negative reinforcement learning is increase the behavior, provides defense to minimum standard of performance. Disadvantages, probably it only provides enough to meet the minimum behavior. This session was an extensive one. I agree. It is complex as well as fun to learn. Thanks for watching and see you again in the next video talking about robotic process automation.